Alright guys, welcome back. Today's intern interview prep video is going to be on linked lists. I made a video comparing linked lists and arrays on TikTok yesterday and it blew up, so I really wanted to give you guys a full-length video, not only going more in depth on my explanations but actually implementing. So today I'm going to be coding in C++ and I'm going to show you guys how to implement a queue using a linked list. Again, if you've followed me recently, if you've subscribed, thank you so much. This is what keeps me going, it gives me the support, and I love teaching, so I just love finding my crew and my people out there who are liking my content, so thanks a lot. So for those who didn't see the TikTok or don't follow me on there, I'll go over what we talked about in that TikTok. So in the TikTok, I was comparing linked lists and arrays as data structures and giving an idea of how both of them work so that you would be able to determine which would be the appropriate data structure based on a given situation. So covering some basics here, linked lists are a linear data structure where the elements are not stored in contiguous memory locations. And I say not stored, they're usually not, they can be, but we build our data structure with next pointers because of the fact that they may not be stored at contiguous memory. So what does that mean? So if we look over here at arrays, which are stored in contiguous memory, you can see here in the simulated memory, the first element A is at address 200, the next element B is at address 201, 202, etc. So they're right next to each other, and that's actually what gives us the functionality of being able to grab elements by their index, because all of these are at a base address and all of these elements are just offset from that base address a certain number. But now we go to linked list and you'll see here that it's not the same. So the first element is at 200, the next element is at 207, 210, so not contiguous. And by not contiguous, it means not next to each other, not adjacent to each other. That's what that means. So that's why we need that next pointer to be able to say, hey, you're not right next to me. Where are you? What's the address of my next item in this list? In an array, we typically call each thing an element, and in a linked list, each thing we call it a node. But both of them store information, whether that be a string, a number, they both store their own data. Now, some key differences that are really important to know is that, like we said, in arrays, we can access by index, and therefore, we can access any element in constant time. So this means that it doesn't matter if our array is 10 of length, 100 of length, a billion, we can access any element that we want in constant time. Whereas linked lists, because they're not stored in contiguous memory, to access a node, you have to traverse through the whole list. Meaning that you have to actually, let's say you want the 17th node, you're going to have to go through 1, 2, 3, 4, all the way through 16 to reach that 17. So you can imagine, in theory, if you have a linked list with 1,000,000 items, if you want to get the millionth minus 1, it's going to take you a while to get there. Okay, and in the context of C++, arrays are of fixed size and cannot be changed during the execution of the program. So they're not dynamic. It means that once you set the size, that's the size, and whether or not you use it all, that's a different story, but you're never going to be able to change it during execution. And linked lists, on the other hand, are dynamic. You can add nodes, remove nodes during the program. Insertions and deletions in arrays consume a lot of time, and it's really expensive because you have to get rid of one, shift all the other ones over to add one. So that's not great. And luckily in linked lists, inserting and deleting nodes is much faster and a lot easier, and I'll actually show you guys that when we get to the coding portion. And the basic structure of our linked list, I like to visualize it like this. So each one of these things is a node, right? Each one of these things is a node, and each node holds data, so whatever it's storing, and then it also holds the address of the next node. So if you see here, these are highlighted and kind of color-coded on purpose. So this is like a little green, lime green. This is holding this address. And then this one, you see it's yellow, it's holding this address. So every node holds its own data, but then it also holds the address of the next node in its list. And the way that we actually hold this address or save this address is with a pointer. And a pointer is just a variable whose memory is the address of another variable. So instead of a variable holding a piece of data, whether it's user assigned or we assign it, it's just holding an address to another variable. So that's how we're actually able to store this next address. And additionally, we use what's called a head and a tail pointer to keep track of which nodes are at the front of our list and which nodes are last. And this enables us to easily iterate through our list, easily to go forward and backwards. And you'll see that again once I get to the implementation part. Okay, so before I start coding, remember what we're trying to implement today is a queue. So a queue is a data structure that has a first in, first out structure, meaning that you add to the back of the structure and you pop off from the front. So a queue, you can think of it as a line. You go get in line at the bank, you get in the back of the line, and you get out at the front of the line. So the two operations that we need to be able to do is add a node, delete a node, print a node probably, but our addition and deletion has to be from a specific place. We don't just want to delete any node or add a node anywhere in the list. When we add, we want to add specifically to the back of the list. And when we delete, we want to specifically delete from the front of the list. So that's what we're going to go ahead and do here. So I just went ahead and set up a new project on Xcode. It's super easy to set up. This is in C++. So we're going to just go ahead and start by saying using namespace std. You guys are probably familiar with this from school. This is just something that I got used to writing when I'm coding in C++. It lets you use some things that you need that I'm going to use. And for now, we're just going to go ahead and just delete everything from our main. We don't need that. So the first thing that we need to do is define what a node is. The computer doesn't know what node is. We have to tell it we're going to be creating nodes, and it's something that we're going to be using over and over. So we're going to do this by creating a struct. We'll just call it node. And remember, for a struct, for a struct. So now we have to tell it what's going to be in the node. So in our case, we're going to be storing an integer that we'll call data. And then we're also going to be storing a next pointer. So remember, right now you're telling the computer what is each node going to have. And in our case, each node needs to be able to store its own data and a next pointer, like we said. If you're doing a doubly linked list, you would also define a previous pointer. But here we're just going to do a singly linked list. So we're going to say node, node, and then next. And we use that little star to define that it's a pointer and not just a regular variable. So now we have our node struct, perfect, and we need to add a semicolon there. And now we also need to define our methods. What are going to be our functions? Remember we said enqueue and dequeue, aka add to the back, pop from the front. So to do that, we're going to create a class and we're going to call it linked list. That's liked. We're going to call it linked list. And open up your curly braces, close them. Remember to add that semicolon because we're in C++. And we're going to go ahead and declare our private variables, which in our case, we're just going to use head and tail. Now, this is just naming convention. You could name this apple, banana, fork, spoon. You can name this whatever you want, but the point of this is to be able to keep track of where your first node is and when your last node is. Specifically, it's going to help us be able to iterate through, and because we're adding to the back and deleting from the front, we're going to be using those two. So we can say node, and again, these are pointers, so we have to use a little asterisks. So cool, now we have our privates, and now we're going to define our methods. And here's where we're going to define the functions that we do. But first, as always, you need to define your constructor, and remember, it has to match the name of your class, so I have to make sure you spell it correctly, linked list. And in this case, all we have defined is a head and a tail. So in our constructor, the only thing we can do is set head and tail equal to null. And that's it. So now we have our boilerplate. Now from here, we can start doing all the other fun stuff. So first off, we're going to do enqueue. So before I actually code, I'm going to show you guys really quick how this. So the first function that we're going to work on is enqueue. We're going to call it that. That's kind of the formal name. You can Google that and you'll find all these answers. But really what we mean is we just want to add to the back. So we want to put something in the queue. So before I get started, I just wanted to show you guys what this looks like. So I'm just going to use circles here for ease. So imagine this is our list, right? This is the front. So we'll label this head and we'll label this tail. So the mechanism that needs to take place here for us to add a new node is this. So we need to define a new node, but the way that it actually gets connected to our list is with this existing tail. So what we need to do is, let's just say we created our new one. It's sitting here by itself in the open. Actually, let me move it down here. So it's sitting over here by itself. It's not part of the list yet. We have a next pointer, which is going to be pointing to null, because if you're the last one in the list, your next pointer should be null. There's nothing else to point at. But now, how do we actually connect it? That's what we need to figure out right here. So we're just going to title this temporary node because it's not part of the family yet, so we'll just call it temporary. So what actually needs to happen? So what we need to do is say tail, take your next pointer and point it to our temporary node. So this says, okay, I'll take my next pointer, and now it's pointing here. Cool. All right, but now tail is still here, and we want tail to be on our last node always, because that's the point of the tail. So now in order for us to move the tail, we have to say, hey, tail, your new assignment is going to be your current next. So then he goes and looks at this and says, okay, who's my next? My next is temp node. Okay, so then you go and reassign, and now this is tail. It's a really simple concept. A lot of students get tripped up on this, but when you draw it out and see what it is, it's really not that hard. All right, so let's go ahead. So this is a function that's not going to return anything, so we have to say void and q, and we know that this is going to take in something, right? And we know that by going to our struct definition, we say that every node is going to have two things, data and a next pointer. So we know right away we need to pass in some data, so in this case we'll just call it int n. All right, cool. So there's two cases that we need to account for. The first case is where the list is empty and this node that is being enqueued is the first node. The second case is where this is not the case, basically where there's already nodes and it's not the first node. So, but regardless of cases, we're going to have to create the new node to start with. So we'll say node, and like in our example, we'll call it temp node equals a new instance of our node struct. That's what this is saying. Make a new instance of this node. This new node has data and next. All right, cool. So now that we have that, right away, also regardless of the case, let's just go ahead and assign the data. So we'll say temp node arrow data equals n. And now that's done. Okay, so our temporary node is made, and now we need to check for the first case. If our head is null, that means that the list is empty. That means that there's nothing else in the list. So we'll say if head is null, then all that means is that we need to assign both the head and the tail pointer to be the one that we just created. So we'll say head equals temp and tail equals temp. And in the case where this is not the first node, we're going to do what our illustration that we just talked about did. So the only thing that we're going to do is we're going to move our tail's next pointer to be the node that we just created, and then we're going to move the tail label itself over as well. So we can say tails next, is going to be the pointer we just created. I mean the node that we just created. And then we're going to say tail equals tails next. And we can do that because we just set our tails next. But if we hadn't done this line, this wouldn't make sense because tails next is null. So you have to remember, first you have to move the next pointer of the tail to be the one you just created. And then that way you can move over the tail by saying tail is now going to be tails. And we should probably add a little text just so that the user sees that it works successfully. So you can say cout and say the node was added. And then just use an end L. Okay. So now that's done. Now we can define our dequeue, which is going to work the same way. It's void. It doesn't take in any arguments because we don't need to pass in any arguments to delete the last one. So it's going to be empty. And again, in this case, we have to account for those two cases where there's nothing in the list, in which case you can't dequeue if there's nothing, and the other case where there is something to dequeue. All right, and for dequeuing, simple enough. We're just going to take off the first node. But if you just go ahead and chop it off like this, now we have no reference to our head, and our whole list is messed up. So we need a mechanism to somehow hold on to that head pointer while still getting rid of that first node. So the way that we do it is we actually create a pointer that points to head. So we'll call this temp, right? So then remember, this is head, but now we're able to store it with this temp. So now we can easily say head equals heads next. So that means we're going to move this whole head to be over here. So now this is our head. And this temporary thing that we created just to hold on to that while we chopped off that head, now we can just delete it. Okay, again, so accounting for the case where the list is already empty, that means you can't dequeue anything. We're just going to send a message to the user and let them know, hey, you can't do this. So we'll say if head is null. And we use head as the way to check because we should always be setting our head, and upon making the first node in the list, we set our head and our tail. So if our head is ever null, it means that if we did everything correctly, that there's nothing in the list. So if head is null, we'll just cout and say nothing in the list to delete. Else, if there is already nodes in the list, we're going to do what we just talked about. So we're going to create that temporary holder to hold what's currently in head. And then we can move head over and say head equals heads next. And then after we've moved that head over, now we can delete that temporary pointer because it was just holding on to that head reference for us. And now we've moved our head, so we can delete it. So we can say delete temp holder. And the reason you delete it is because if you don't delete this, you're eventually going to have a memory leak. So you have to manually delete this stuff that you're not using anymore. And let's just add a message to let the user know that this function worked correctly. Okay, cool. So now we have our NQ, we have our DQ. So the last thing we need to add is our ability to print these just so that we can make sure that these functions are working correctly. So again, this is going to be a void function because we're not returning anything, and we'll call it print all. This takes no arguments. We don't have to pass anything to do this. And we're going to go ahead and create a current pointer. So all that's going to do is it's going to be the thing that's actually iterating over our list. But first, what we need to do is check if the list is empty. So again, we're going to say if head is null, then we'll just print to the user, hey, there's nothing to print here. Okay, cool. Else, if there is something to print, we're going to create this iterator. We'll call it iterator. And we're going to set that iterator to be at head because we want to start it at the beginning. In theory, you could also iterate backwards. You could start this at the tail if you had a previous pointer, but because we're a singly linked list, we have to start it at the head. And we're just going to use a while loop. We're going to say while iterator is not null. So while we have a node to work with, while it's not null, we're just going to see out the actual data. So we'll say iterator data, and I'll do an end L there. And then we're going to move our iterator over one. So we have to say iterator, now I want you to be your next. Which in the beginning, it's heads, but as it moves through the list, it's not head anymore. That's why we had to create this temporary iterator to have something to reference as we move through this list. And actually, instead of an end line here, I'm going to print these little lines with an arrow just to visualize that next pointer. So this isn't, you're not going to be able to see this really, but I'm printing this out to kind of make it so that you can visualize what a next arrow and a next pointer would look like once we print these out. Okay, so now in our main, I'm just going to make a little menu so that a user can select an operation, whether NQ, DQ, or print. So first we have to create an instance of our class. So we'll say linked list L. So now we have that instance, and we're going to have to define an int variable that's going to map to the user selection. So we'll say user selection. And now we're actually going to write all this down. So I'm just going to copy and paste all of these options so that we don't have to go through these. So here's going to be the menu. They can choose 1 to NQ, 2 to DQ, 3 to print, and 4 to quit. And I called this user selection. So here, this line 74, is actually saving what the user inputs to our variable user selection, which will be 1, 2, 3, or 4. Then we can just add a switch statement, and Xcode is really cool because it actually sets up this template for you, and the variable that we're going to be switching through is user selection, right? Depending on what they select. The first case is NQ. So the thing that we want to do there is we want to ask them for the data. So we're going to say enter the data for this node. And then we actually want to save that into a variable. We'll call that input, so that means that we have to declare that, right? So we'll say int input. So save that into input, and then we're going to actually call that. So we have to take our linked list instance L and then call NQ, and we're going to pass in input because that's what we just asked the user for. And then we can go out here and say case 2. So remember, case 2 is DQ. So we don't have to ask them for any input. We can just call the function L.DQ. and then add our break. And then finally for case 3, this means that they just want to print. Also, we don't need to take in any arguments, so we can just call print all, add our break. Cool. So now when the user runs this, they're going to see this menu. Where do I need a, oh, here. They're going to see this menu, they're going to be able to pick, but right now if you notice when main runs, they're only going to be able to select one thing. So we need to wrap this in a while loop so that the user can keep on adding and deleting until they want to quit, because right now there's no option for them to do more than one operation. So we'll wrap this whole thing. So basically, while the user does not want to quit, so while user selection is not 4, keep showing them this menu over and over. So I'm just going to delete this and paste this whole thing into that while loop. So all the way up to here, because we want this menu to take place over and over until they press 4, which is quit. Okay, so now let's run this. So I'm going to NQ in order again. 1, 2, 3, 4, 5. So now when we press print, we should see all of these with that arrow that I added. So cool, that worked correctly. So we see here we have 1, 2, 3, 4, 5. That's exactly what I added. And this is pointing to null. It's the end of our list, so there's nothing there. So now let's add one more just to as a sanity check. So I'm going to NQ, so that means I should have whatever I put here should be at the end. So let me just add a 100. So now when I print, it should be 1, 2, 3, 4, 5, and then 100 at the end. Perfect, so that works. So now let's check our DQ. So remember, this doesn't take in any arguments. So as soon as we press 2 and hit enter, that should pop the 1 right off. So when we print it, it should be 2, 3, 4, 5, 100. And that worked correctly. So let's do a few more DQs. Okay, so now 3 is our head, DQ again. Now 4 is our head, DQ again. 5 is our head, DQ again. All that's left is 100, DQ again. The list is empty, nothing to print. So that worked perfectly. So now if we hit 4, we'll exit out of our program, and that all worked.